This video shows how ZOS open source tools can be used to build, and test a legacy project on ZOS. For evident reasons, we can't show the source code of a real product. So we will create a simple project that uses legacy programming languages. Here we have several source code modules in a dataset. For the sake of simplicity, they all are just hello world programs. There is a C program, COBOL program, and PL1 program. Okay, so this is the project we are going to use, and it can be built using a build.json. Here is the example. When modernizing the development procedures for a legacy project, the first thing to do is to place all the source code into a Git repository. To do that, we need to copy dataset members into USS file system. As a result, we have a directory with 3 files with source code. From now on, the source files can be edited not only in ASPF, but also directly in USS using Vim editor. Okay, now let's create a Git repository for our project. It's one command, git init. Important thing to note is that files in USS can be stored in different encodings, either in ebcdic or in ASCII. We need to tell Git what encoding is used for source files. This can be done by adding a file with Git attributes. Let's copy this file from another project. Here is the content of the file. Okay. So here we specify the encoding using ZOS specific attribute ZOS working tree encoding. When a file with this attribute is added to the repository, Git converts the content of that file from the specified encoding to UTF-8. Finally, Git stores UTF-8 encoded content in its internal data structure that is called index, and when on checkout, the content is converted back to the specified encoding. If a file doesn't have ZOS working tree encoding attribute, its content is never altered when file is copied between the working tree directory and the index. Some files used by Git itself, like Git attributes or Git ignore, must be always encoded as ASCII. Now let's use Git commands to add files into the repository. There are 2 commands, git add. We add them to the index, and next one is git commit to fix the changes. Okay. Next step is to modernize the build process. We are going to replace the build.json, which we previously showed, with the tool named make. This tool allows to build the project step by step, depending on what source files have been modified since the last build. To use make, you must write a file called makefile that contains instructions on how to build individual files in the project. And here is the example of makefile, which we will use for our project. As you can see, we are using native USS compilers for programming languages C, COBOL, and PL1. And also, we are using C89 utility as a link editor. Now let's run makefile to build the project. Okay, as you can see, the project has been built successfully. Nowadays, testing is an important part of the development pipeline. And let's create a bash script, which is called test.sh, to test the compiled programs. This is the content of the file. As you can see, it runs each program and compares the output of the program with an expected string. We just run the test file, and we can see that all tests have been passed successfully. We need to add the changes, makefile and test.sh to the repository. Again, the same commands, git add and git commit. Okay, so now since we are able to build our programs without errors and tests are passed successfully, we have to push our local repository to remote server. In our demo, we use GitHub. So GitHub is a platform that provides a lot of features, and at the same time it is free for some projects and for open projects. It provides such features like commit history, code review, pull requests, difference between commits and branches, and many other features. So, as you can see on the screen the content of Git repository on GitHub. Okay. To automate our development pipeline, we use Jenkins. Jenkins is running on x86 platform. In our case, it's a Linux machine. We need to create a one Jenkins job that connects to USS via the SSH protocol and run commands to prepare project for building, to clone repository, then to build, to test, and we will also post test results on Jira. So this is the example of Jenkins jobs that is used. Okay, now let's run it. We have to specify task ID, ticket ID, and some command which we are going to add to the ticket. Okay, the build is completed and we can go to Jira to see if the comment appeared. Yes, it's here. And here is output with test results. Okay, and that's it. Of course, it's not the only one possible way to use open source tools with legacy projects. The pipeline that we just demonstrated can be modified as necessary. For example, we can place compiler output directly to MVS datasets if needed, and we're going to show you how to do that. Some legacy languages cannot be compiled in USS. This can be handled by creating a Rex script or GCL to build the source code on MVS. The script or GCL is then run from the make file. As an example, we create a Rex script to compile the COBOL program in MVS. This is one example. And GCL to compile PL1 program as a batch job. Both scripts are run from the updated make file. Here is it. And in addition, C program is compiled in USS, but we will place linker output to MVS dataset. Now we run make, and let's see the result. Okay, we have the output in dataset. Okay, and all the tools that were used during this demonstration are included into Rocket Open App Dev for Z solution. All the tools are installed using Conda Package Manager, and here you can see demonstration how to install a new tool in our a new package. All dependencies were installed automatically. Also, if you want to update package to a newer version, it's one command as well. Here is the example. Okay, we successfully updated curl to a newer version. Okay, and that's all. Thank you for your attention,